So I was working on my new game and working on one of the new mechanics when I encountered a really interesting problem. Now, the only thing you need to know about this problem is that there are 4 teams, and each team has a relationship with all of the other teams. And so I had to figure out how I would represent those relationships. And my idea was an array, where each element in the array was a relationship between 2 teams. And so I was thinking about it, and the idea I came up with was an array with 16 elements. The reasoning behind that being a table I had envisioned, where along the top you've got one team, like Team A, and along the side you've got Team B, and where the column for Team A and the row for Team B meet, the cell that is there is the relationship between those 2 teams. And I drew it out so I could kind of see how it would work, and I noticed that there's a pretty big problem with that. For a team's relationship with itself, it's fine, but for any relationship between any 2 differing teams, that information exists in 2 places. Like, for example, with the red team's relationship with the blue team, that information exists here and here. And for, like, say, the green and the red team, it exists here and here. So obviously that wasn't the right way to go about it. And I was thinking about it, and I remember seeing something like this before. And where I had seen it was the layered collision matrix in Unity's physics settings. Over here they have the layers listed in ascending order along the side, descending on the top, and it's a triangle-shaped row-column match thing. So I thought, okay. So I did that. And I found out that I only needed 10 elements rather than 16. And at the time I was a little bit curious as to what the math behind figuring out how many elements you needed was. And I didn't know, and it would turn out to be pretty important that I did know later on, but at the time it was just something that I was kind of curious about, and hey, it would be kind of cool if I knew, but it's probably not important right now, right? Well, it was. So my current problem at that time was figuring out how to turn the pair of team numbers into an index into this array. And so I was thinking about it, and I was pretty sure that the indexes, or the indices, would go from right to left, from top to bottom. So I laid out what the actual indices would be. It would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I was trying to look for patterns related to those indices versus the numbers that they came from. And keep in mind that the array looks like this. This is not very intuitive. Like if it actually came from this. So I was thinking about it, and on the way to the solution of the problem, I came up with this. I would generate an index in base 4 where the larger of the 2 numbers was the lower number and the smaller was the upper number. I was looking at that, and now my next problem was, well, for any rows that aren't the 0th row, the indices need to have some number subtracted from them. And so I looked at those numbers, which turned out to be 0, 1, 3, and 6. And then it was time to try and find a pattern relating those numbers to these numbers right here. And it took me a long time to figure it out. I couldn't really see it at first. I was hoping it would be some really nice linear equation, or maybe a quadratic one, but I just really wasn't sure. I was hoping for a nice linear equation, but I couldn't really find one. So I kept looking and kept thinking and just trying, and eventually I figured out, and I saw a pattern. So this is a graph that would have been a square, and I noticed that there's a certain number of squares removed from it. And I figured out how you find out how many squares it is. You sum up all the numbers below the width or the size of that grid. So, for example, if you have a grid with a size of 4, you add 3 and 2 and 1. Then I thought, well, that's like a summation operation. That's something you have to iterate through. Isn't there some formula for that? And I kept trying to figure it out. And I actually came up with the solution completely by accident. It turns out that what you can do in all actuality is take the number, add 1 to it, multiply those together, and divide it by 2, and you have the sum of all numbers from that number to 1. I didn't know that at the time, but I stumbled upon the solution for that by accident. And when I simplified and combined like terms and stuff like that, I ended up with something like x squared minus x over 2 plus x. However, in this case, x is replaced with little I, which corresponds to the row number that we derived over here. And so I finally had the formula for what I subtract from the row number to get the true index. And yeah, I'm really proud of how I figured this out. If it sounded like I was looking stuff up when I said I was looking for a solution, I meant I was just looking through my brain, looking through the patterns, looking through the numbers to actually try and find patterns. And it actually happened by accident, but I do know now what the actual formula for deriving that was, but still don't understand exactly why. But for my case, that's okay. I have a formula that works, and I'm happy, and I wanted to share it with everybody because, like I said, really proud that I figured this out. But anyway, thanks for watching. Bye.